Hello everyone. In today's session, we'll review the Ricardian model of trade, which uses differences in technology across countries to describe why countries trade with each other, and also will be able to show that the countries benefit from this trade, which is going to be based on comparative advantage that these countries have. Okay, so the first thing we're going to do is we're going to set up a model for a closed economy, which can also be referred to as an economy which, when there is no trade, or a country under autarky, right? So these are the three terms that I used for to describe a country which is closed and does not trade with another country. Okay, so we're going to assume a few things and make certain assumptions, which is going to help us to solve this model. And so for this country, for the home country, we're going to assume that there is only one factor of production. Okay, and that factor of production, or that input, is labor. Okay, so it only uses labor to produce goods. We're going to assume that this labor is homogeneous. That means each individual labor unit is exactly the same. They have the same level of training, same level of education, and so on, and which then will help us to assume that labor is mobile across two sectors. So we're going to assume that this country produces two goods, and these two industries, or two sectors, as we might refer to them at different times. The labor is mobile across these two industries, so that there's no specific talent that is needed for these sectors, which makes it easier for labor to move from one sector to another. Okay, we're going to assume that two goods are being produced by this country, and that the factor of production, or the input, or the resource that this country has, is fixed. So the supply of labor is fixed in each country. Right now we're talking about one home country, but we will also introduce a foreign country. And so we're going to assume that that supply of labor is fixed. Now the trade is being explained on the basis of differences in technology in the Ricardian model, right? And we are going to define this technology in terms of productivity of labor. Okay, so how productive labor is in the production of these goods. So we're going to allow for this productivity or technology to differ across countries. But at the same time, we are going to assume that this technology or productivity is fixed for each good. That means for one good, it doesn't change over time. Okay. We're going to assume that there's perfect competition in all these markets, the two goods markets. And we are going to then try to provide some numbers so that it becomes easier for us to understand this model. And we're going to assume that the total labor supply that exists in the home country is 120 units or 120 workers. Up to you how you want to think about this. And sometimes I'll refer to this as 120 units. Okay. So these are some assumptions that we are making. There are going to be more assumptions once we introduce the foreign country as well, and we'll discuss those as we get to that. Okay. Now, we have assumed that productivity it differs across countries, but for the home country, for this country, we are going to assume that labor productivity is constant for an industry. Okay, it doesn't change over time. And so this constant labor productivity is going to be modeled by something that we refer to, or we term as unit labor requirement. Okay, now unit labor requirement, the definition for unit labor requirement is, in order to produce 1 unit of labor, okay, unit labor requirement, to produce 1 unit of output, how much labor do you require? Okay, and that is the formal definition. Now, if you think about this, it's really the reverse of something that you've been introduced to before, which is marginal productivity of labor, right? And when we think about MPL, the question that we think about is, with 1 unit of labor, how much output do you produce, right? When you increase labor by 1 unit, what is the increase in output? That's marginal productivity of labor. 1 unit of labor, how much output? But unit labor requirement is the inverse of MPL, or the marginal productivity of labor. The question that you ask here is, 1 unit of output, how much labor do you need? Okay. Now we're going to define this labor requirements for the two industries, and we're going to assume that this country produces cloth or coffee, and the second good that it produces is wheat. Okay, so in the home country, there is the unit labor requirement, or the technology is such that the ALC, which is unit labor requirement for cloth or coffee, I'm going to refer to this good as C, and wheat we're going to term this as W. So ALC is equal to 1. What that means is that in order to produce 1 unit of cloth, we need 1 unit of labor. Okay, and for wheat, the ALW is 2. What that means is that to produce 1 unit of wheat, we need 2 units of labor. Okay, now we're going to ignore these numbers for foreign country right now, to stick to the home country. Now moving on, we using what we have been provided, the total labor supply and the unit labor requirements, we are now going to arrive at an equation for the production prosperity frontier. Before we move on to that, the PPF, what is a production prosperity frontier? Well, it is a frontier that shows us the possibilities of producing the two goods given the limited resources a country has. Okay, so the constraint is being provided by the limited resources. Okay, so how much we produce of the two goods of C and W really depends upon how much labor do you allocate to the C sector, and let's go back here. How much labor do you allocate to the C sector, and how much W you produce would depend upon how much labor you allocate to the wheat sector. Okay, now so the allocation of the allocation of labor in the two sectors would equal to the total labor supply that we have in this country. Yeah, now this is the constraint for the production prosperity frontier. Yeah? Now, how we're going to derive or draw this graph is by the two axes in that case measure the quantity of the two goods. Yeah, it doesn't measure the labor allocated to the two sectors, but the PPF is drawn between the axes that measure the quantity of the two goods. Okay, so how much quantity of cloth would be produced? Well, there are two ways of doing this. We can first of all try to assume that the country spends all its labor. So let's do that. The first step we're going to do is, suppose all the labor is allocated to the C sector. If that is the case, given that ALC is equal to 1 and given that total labor supply is 120, what is the maximum amount of C the country can produce? Okay, so let's ask the question again. How much quantity of C can this country produce given that it uses all its resources for the production of C? Okay, so 120 is being used, and ALC is telling you to produce 1 unit of output, how much labor do you need? And ALC is equal to 1. So how much QC is produced? Well, the amount of QC that would be produced if all the resources are being used for the production of C is going to be, it is the maximum. Okay, so that guys, we're looking at the maximum right now. It's 120. Okay, yes, please excuse my handwriting here. And we're going to ask the same question for QW. Okay, if we spend all our resources in the production of wheat, not we, but the home country, how much wheat can this country produce? Well, total labor supply is 120, and ALW, the unit labor requirement, is 2, which means in order to produce 1 unit of wheat, the technology requires 2 units of labor. So if you were to use all labor, 120, in the production of wheat, how much wheat do you end up producing? Well, you end up producing 60 units of wheat. Okay. Yeah. So if we were to plot this, we now have the maximum outputs. We now have the intersection of the two axes here. Okay, we'll get to that later. And when you did this question for us, what quantity of W is produced, what you really were doing with the answer of 120, what you were really doing was you were saying, well, what is the total amount of labor supply, and let's divide this by the unit labor requirement in the wheat industry. Yeah. Okay. So if QW is equal to L by ALW, yeah, then the LW would be equal to ALW into QW. All right, so let's do this again. If LW is the amount that you're spending in the production of wheat, yeah, and if we had to convert this into in terms of quantity of wheat, this is what you had. I'm going to put LW here because the question was being asked if you spend all the labor in the wheat sector, LW. So if QW is equal to LW by ALW, what is LW? Well, you multiply both sides by ALW, and you have QW into ALW is equal to I'm writing this on a Mac, so do pardon my handwriting here and the speed as well. Okay, so we have LW. Okay, so that's what we did here. We substituted the term ALW into QW. Okay, and we do the same thing for ALC into QC. That would give us LC. Okay, now substitute the value of ALC and ALW. That's 1 and 2, and L, which is 120. Okay, and we have this equation, which is a production possibility frontier. We also know that if, this is interesting, if you produce no coffee or cloth in this case, and you produce all W, how much wheat can you produce? Well, if this is 0 and you're only looking at wheat, then how much wheat do you end up producing? 120 divided by 2, 60. And that is the answer that you gave us before as well. Yeah, so we realize that our equation that we've come up with is exactly right because it gives us the right answer here. Now, the next step for you guys to do is to draw this PPF, okay? To draw this production possibility frontier. And that's what we're going to do in the next slide, okay? And this is what our PPF looks like. We do have the two intersection, and we are measuring on the two axes quantity of wheat and cloth. So on this axis, it is wheat. On the y-axis, on the x-axis, we're measuring cloth. So what we have here is, if you produced 0 amounts of wheat, how much cloth can you produce? Well, 120. So this point of intersection that you guys have here, this point of intersection that you have here is the amount of wheat that you produce, amount of cloth that you produce, given that wheat is equal to 0, it's 120. Well, if you were asked the same question for the other sector, if you're producing 0 amount of cloth, how much wheat would you produce? Well, you'll spend all your labor in the wheat sector. This would be 160. So we have the two intersection points, right? 60 and 120. And then the question arises, well, why isn't our production possibility frontier bowed outwards like it generally is? Oh, why? That is really a lousy way of doing it. Okay, why isn't it shaped like a PPF that you're used to seeing in Econ 101? Well, the reason why the shape is a straight line is because we are assuming, all right, this is important, we are assuming that the unit labor requirement or the inverse of the marginal productivity of labor is constant in case of the Ricardian model, right? So there is no change in unit labor requirement, which is actually the inverse of marginal productivity of labor. That is, there is no diminishing marginal productivity of labor. And if you recall from Econ 101, the reason for that curved shape of the PPF was because of diminishing marginal productivity of labor. okay, which we do not have in this model. Why not? Because from the start, one of the assumptions that we made was that your unit labor requirement or the labor productivity stays the same for an industry. It doesn't change irrespective of how much labor you employ in that sector. Okay. All right. So now we have the production prosperity frontier for the home. So for this country, for home, we want actually to we are setting this up, right? We're setting up a model for the home country. So what all do you need to have a model which actually depicts the country? Well, we need to have the production side. Yeah. So we are looking at, when we think about the economy, we're thinking about the production side and we're thinking about the consumption side. Okay. So these are the producers and these are the consumers. So production side, we have just set this model up. How we thought about the production process, we thought about technology, how many goods are being produced, and how much input is, or what kind of input is needed. So we have covered the production side. Now, production side is the important part here, right? Because Ricardian model is trying to explain trade on the basis of differences in technology, and technology figures in to the production side of the economy. Okay, not the consumption side. So for consumption side, we are just going to be using the general framework that we are accustomed to. We're going to represent the consumption side by indifference curves. Okay, and so that is as far as the overall model is concerned. Now we're going to solve this production side further. Okay, and how are we going to do that? Well, we now know what the production prosperity frontier looks like. Okay, we know we are here, but we don't know at what point on this PPF does home country produce. Does it produce up here? Does it produce at this point, all wheat and no cloth, or does it produce at this point? Well, that would depend upon our consumption side indifference curve. And the other thing that we want to know is, well, what are the prices for these two goods? Remember, we are going to introduce another country, foreign country, and the technological differences are going to bring about differences in prices of these two goods across countries, which in turn would motivate or would result in trade between these two countries. So we actually want to use this model to come up with equations or come up with a measure for the prices of these goods, for price of cloth and price of wheat. So that's what our goal is for the next 2-3 slides. We want to derive the price of these two goods. And in doing so, we would also be thinking about the wage that is being paid to the labor, the only factor of production that exists in this model. Okay, and in order to do that, we are going to rely on the fact that there is perfect competition and zero profits are made. So we have marginal revenue is equal to marginal cost, but there is something else that happens in case of a perfectly comparative industry, and that condition is, we'll talk about these. That condition is that the value of marginal product of labor, okay, is equal to wages. What does that mean? That means that because it's zero profits, whatever the value that is added by the input, yeah, is the unit wages that they receive. I'll rephrase that. If I'm a worker, I should be paid equal to the value that I add to the output. And that's what I'm doing. That's what this equation is saying. The wage that I get for that 1 hour that I have worked should be equal to the value that I have added, marginal productivity of labor, I have added to that output. Okay? Because remember, what is marginal productivity of labor? When you increase the labor by 1 unit, what is the increase in output? Okay, so this is measuring the increase in output, the quantity, And if we want this in terms of value, we will multiply it by the price of the good, okay, but the price of that good. So that's what this equation, this next line is referring to. The value of marginal productivity of labor is equal to the price of the good times the marginal productivity of labor. So all you're doing is you're converting this quantity, because this isn't going to be in terms of units, right? You're turning that into a value by multiplying it by the price of that good, the unit price of the good. And in this model, given that there are zero profits and given that whatever you add to the output is the wage that you get, we have this as the condition that is going to help us derive our prices, that the wage should be equal to the value of the marginal productivity of labor. Okay. If there were other factors of production, this would apply to those factors of production as well. The price that you pay to those factors should be equal to the value that they add to that output. Okay. Now, this gives us a lot of explanation about how this model is going to work, right? It will also tell us how much labor to apply to employ, and it will tell us how this equality is achieved as well. Don't worry, we'll get to that in the next slide. So before we go on, we are going to now just talk about how we denote these different terms. Okay, so PC is going to be referring to the dollar price of cloth. So this is price of cloth. Okay, PW would be price of wheat. WW would be the wage in the wheat industry, and WC the wage in the cloth industry. Okay, W is the general wages, and VMPL is the value of marginal productivity of labor. And MPL is going to be used for marginal productivity of labor, but also remember that we have something called the unit labor requirement, which is ALC from the previous one. Okay, so sometimes we are going to just think about VMPL, which is just price into MPL, and sometimes we're going to write this out separately as MPL into price. Okay, and so I just want to put this down in a statement as well on the slide. We've been talking about this, the fact that marginal productivity of labor is actually the inverse of the unit labor requirement. Okay, and if that is the case, yeah, let's put those in terms of equation. That means, are you guys here with me? Yeah, so this is marginal productivity of labor. Yeah, so what is the value of marginal productivity of labor? Well, it is price into MPL. Yeah, so if you multiply this by the price of what? The price of the good, which is hiring labor, which is the wheat sector, PW. Okay, yeah, so that gives us 1 divided by LW into PW will give us PW by LW. So this is the value of marginal productivity in the wheat sector. Similarly, you'll have that for the cloth sector as well. Okay. Now, here is a question that is being asked of you. Okay. So suppose now that you are the producer, okay, and when you hire workers, you are going to pay them an amount that is equal to the output that they are adding to the final output, the value that they're adding to the output. So would you then hire them for the production of wheat if the wages that they were charging in the wheat sector was more than the value they were adding to the output? That means you pay them more than you get for them when you sell their product. Well, in that case, you won't hire them, right? Because you're paying a higher wage than you receive in terms of the value they're adding to output. So if this inequality, the producers face this inequality, or whenever they have a wage that's higher than the value of marginal productivity of labor in the wheat sector, there will be no production of wheat. Yeah? Producers will not produce wheat. Hire labor to produce wheat. What if it was equal? Well, in this case, they would produce because they pay them a wage which is equal to the value that labor adds to the output. And I will let you guys go through the same reasoning and use the same reasoning to understand the other two terms. But what we are supposed to get out of this is the fact that PW by LW is equal to WW is the equation would hold if wheat has to be produced in the economy. Yeah, and the same thing will happen when you are thinking about producing cloth. This would have to be held. Yeah, so in a country, home country, if a home country produces both the goods, wheat as well as cloth, then these two equalities would have to be met. Okay, all right, sounds good. All right, so let's pause here for this section, and I'm going to ask you guys a question, which is, how do you think this economy going to work if WC is equal to WW, or WC is higher than WW, or WC is less than wages in the wheat sector? Let me rephrase that question. My question to you is, in the home country, what can you say about the wages in the two sectors from what has been given to you? Is it equal? Is it higher? Or you don't know? Okay. Now, in order to answer this, what you would need is to refer to the assumptions that have been made in this model. Okay, so I would ask you guys to go back to the assumptions and then think about the relationship between the wages in the two sectors. All right, guys, I'll pause here for now, and we'll finish this off in the next tutorial.